Hi there, and welcome to another CAD how-to video. I decided in this video to keep taking a look at Onshape. It is in a lot of cases, free, web-based 3D CAD program created by some of the same folks that originally created SolidWorks, and so far, it seems like it may actually be a reasonable replacement for some of the more expensive and harder to obtain CAD softwares. So in the first couple of videos of this series, I created a couple of plates. I mated them together to create an assembly. In this video, I want to see how this sort of handles inserting and uploading parts. And again, I've never done this before. I'm recording these through my first run through Onshape. So far, I haven't run into anything that's too deal breaking in usage or the fact that it's browser based. I mean, the biggest thing is as I sort of rotate my model, the biggest thing is there's a little bit of lag as I move my mouse around. Um, but all in all, it's not too bad. I mean, especially for the price, which is nothing, right? So what I'd like to do is I've got my sort of two sample plates here with counterbore holes. These are quarter 20. And the first thing I'm going to do is I'm going to grab a quarter 20 model from McMaster of a screw and drop it in here and see how this handles an import of a SolidWorks part format. Most CAD programs can handle imports. Now, I may not be able to import SolidWorks native files, which is fine, because as well, things like IGES and STEP files are designed for sort of universal import. So if it won't import the SolidWorks, I'm fairly confident I can somehow figure out to import a STEP file, which McMaster also provides. So first thing I want to do is I want to know how long I need the screw to be. And so I'm going to play around and see if I can't figure out how to get Onshape to take a measurement for me. In SolidWorks, I would select this surface, there we go, that surface there, and I would select the surface under here and just do a evaluate measure command, but I'm not sure here. So for now, I've got those two surfaces selected, the bottom of the plate and the bottom of the counterbore. And let's see if we can't figure out up in our tools here if there is a way. Ooh, it actually looks like we have some simulation options here, which are kind of cool. Create part. We got some relations, some mates. Is there an option? These look like all mating relations. We've got tangency, we've got group snaps. I'm not sure what snapping will do. That would be something to look at later. And I don't actually see a way to measure. Oh, as I'm looking around, I do show measure details down in my bottom right hand corner. That is cool. So sort of like how Microsoft Excel does it, where if you select cells, it automatically gives you the total. Here I've got a parallel distance of 0.75, which is exactly what I wanted to know, right? So I need a 3/4 inch long screw, probably just a little shorter, just to guarantee that we don't sort of pop through the back. But so let's hop over to McMaster and see what we've got. I've already got the screws open, and I knew I needed a socket head cap screw. I'm going to narrow down to quarter 20. And thread length, we're going to go, let's go 5/8, just short of 3/4. I'm just going to grab one, go to my product detail. I'm going to start by downloading the 3D SolidWorks. So that'll give me a SolidWorks native part. And let's see here, if I can insert a part. Now it automatically wants to pull in the two that I've already modeled. We've got sketches, insert entire part studio, other documents, standard content. Oh, it has some standard bolts in it as well. That is very cool. Some standard hardware. Well, let's check while I'm here. I mean, we might as well. Let's see, bolts and screws class. I don't want a countersunk. I would like a socket head. There we go. Socket head cap screw, socket head cap screw, not a button head. There we go. Quarter 20 there, and drive type hex length 3/4. We'll go 5/8. Cool. That is kind of cool. Part number, we can probably define one. What I would typically do in SolidWorks is, I think I've mentioned in previous videos, I tend to model my own screws because the SolidWorks models the entire helix of the thread. And if you get like an entire machine and you're showing all the screws, those surfaces take time to render, and when we've got hundreds of screws in a machine, just the screws can really, really, really slow down an assembly and slow down SolidWorks performance. So I prefer to model my own and use cosmetic threads, just because I don't see a real reason to show all of those helixes, right? Um, and it looks like if this is the part that's going to come in, it looks like um, they're not modeling that thread. So I'm going to insert one. We'll see how it goes. Insert. Okay. Undo to remove instances. It looks like it popped way too many in. So let's, oh, how do I do that? Undo, Control Z. Control Z works. Cool. So let's try that again. It popped. So I still had selected this counterbore surface along with the bottom of the plate, and it put one on that counterbore and four on the bottom of the plate. So I'm wondering if I select all four counterbores and insert the screw. Oh, that is cool. And if I accept, I'm going to see, can I make this wider so I can see? Yep. They don't have now looks like in Onshape, there's a little axis symbol, a little isometric axis here that indicates when things are floating, but it doesn't look like these are. These are, and it added a bunch of fastened mates, which I'm assuming means that we're totally locked down. Like, can I drag? I can't drag those screws. That is kind of cool. Um, Standard hardware sort of involved, and it even looks like if I wanted to, I could change the library to sort of put apart. What I started to say is when I model my own screws, I tend to list this McMaster car part number as the part number of the screw, and I'll put like a note that says, McMaster car part number this or equivalent. And I do that just so that when somebody looks at this, they know, 20 years in the future when they go to do maintenance on this machine, they know at least one location where they can get this screw, one vendor where they can get it. So I always do that, the McMaster part number or equivalent, because McMaster has just about everything. But those screws are already in there, which is kind of cool. Now the question becomes, why so many? Why do I have 8? So I'm going to go through and I'm going to delete some of these extra ones and see what I get. Okay, so I don't want to delete that one because it actually deleted 2. It looks like it, for some reason, inserted 2. I don't understand. I'll have to play around more with this feature. I'm not quite understanding why we got 2 copies in each hole. And actually, to test that, why, I'm going to select this one, and I am going to delete it. And instead of selecting this face, what if I select this diameter and insert standard content, ANSI and screws both good, insert. What if I insert it into the diameter? All right, it's there. It only inserted 1, so that's better, but I'm backwards. And why am I backwards? That's the question. Accept that. Can I change this? Can I change this? If I right click, edit, offset, reorient, flip. Okay, none of that actually, the flip, I mean, sort of worked, but you can tell that it moved it. So this is going to be a feature that I'm going to have to play with a little more. I do kind of like the fastened, mate that it has, and I do like being able to sort of automatically insert that. I'm just not nuts about. So what if I delete all of these? Can I select multiples with a shift? I can, but I don't want to delete that part 1. So deselect. Let's get these 3 out of here. And if I delete these, what happens if I select this face like I did on the bottom and do the same insert? Standard components, let it all populate, insert. Okay, yeah, it popped them up here. So that's something I'll have to play around with. But that does seem like an interesting. Now wait, I may have an idea. I selected, let's get rid of these again. So select the joys of doing videos on the sort of on the cuff, right? On, stream of consciousness. I selected this diameter and it put the screw flush. So what if I select this diameter? Well, let's deselect them all. Select the the surface. Thank you. The counterbore diameter. And what you're seeing, I mean, I'm talking in real time. And compared to, hearing me talk and hearing Onshape react, I hope can get a feel for sort of the lag we're looking at, which again isn't a real big deal breaker, at least for me. I've been doing industrial controls long enough. You spend so much time downloading and waiting for things to download and reboot and all that good stuff. So that you develop a certain sense of patience. So 3 out of the 4 came in the way I was expecting. Why did that last one not? I'm going to get rid of that one. I'm going to try it just one more time, and then I'm going to actually go back to the original purpose, which was, attempting to import a part. So insert. All right, and that one came in fine. Maybe I had something wrong selected. Um, but that one came in fine. They're locked down. I kind of like that feature, sort of standard hardware. Now, SolidWorks 2 does have standard hardware libraries. I got to be honest, I've never played with them much, but it's a thing that is there, so I don't think it's an earth-shattering feature. It is kind of cool. I'm going to go ahead and get rid of these because, again, I want to see what happens on an import. So I'm going to insert, right? I don't want the standard. What do we have in other? Shared with me, public, search or paste URL, current document. Let's not do any of that. Maybe we have to create a new part first. I don't see an option for importing. This has to do with the entire project. So let's create a new part studio so that we get a new part. And now that I'm in here, do I have the option to import geometry? Is there something up here maybe in features that allow me to import? Transform, versions, create versions, comments. So this is some collaboration stuff, as well as the PDM. I am not seeing an easy way to bring in external parts derived. Most of these features are features that are in SolidWorks. I haven't done videos on some of them yet, but most of them are things that exist in SolidWorks. Like there's an external thread that would be cool. That would be sort of our cosmetic thread. Well, I guess I don't need this part studio, so I'm going to go ahead and delete it because I'm not seeing a way to. So how do we simply just fasten to the origin? That's fine. I don't necessarily want to filter. I don't need to search. I've only got the 2 parts. So how do we bring in replicate, show mates? These are all mate commands. Insert part, current document. This may not be as simple as owned by me, created by me, public. Search or paste URL. I don't want to do that because I have a feeling that's going to point to, I mean, this is a web-based system, so I would imagine there's a URL associated with, I would imagine anyway, sort of everything that I create. There's no documents. This is, again, these are the only documents I've ever created. So, well, that is interesting. I guess I will have to play with ways to make that happen. We've got App Store, view all actions. It looks like we've got some different create part studio and context. We've got some different, looks like what would be analysis type features here, which would be cool later for some simulation and some maybe some FEA. I don't know. Those would be like mechanical mates. These are just some more mate options, advanced mates, and sort of standard mates that SolidWorks has as well. I am, again, not actually seeing it. So what I'm going to do, I mean, just for the sake of of the assembly right now is I'm just going to go back and I'm going to select my counterbore surfaces here. And I'm just going to reinsert those standard screws that come with it, I guess, for now, and move on with playing around, because the next step I'd really like to explode the thing, and then move on to creating drawings and seeing what that looks like. So just for the sake of getting moving, as I play around with the software here, we'll do that. And I mean, I've got screws just about that fast, so that it can't be all bad, right? Um, yeah, so we'll go ahead and call the video right there. Um, Interesting, and again, I'll have to play around some in the future with how to import parts. I got to believe in a modern CAD system, there's a way to import existing models. So I'll play around with that, but we'll call this video good right here. That's a way to get some screws inserted all at once out of a standard library. I'd like to thank everyone for watching, and I look forward to seeing you in the future in another CAD video.